Hi, I'm Joe James. In this video, we're going to learn how to slice, select, and filter different rows and columns of data in Pandas. So we're going to learn a variety of different techniques for doing this. We're going to use two different data sets, and both this notebook and those two data sets I'm going to post as usual on my GitHub site, and I'll post a link down below in the comments so you can download the data sets and the notebook and run all this code yourself. So we're going to start with some import statements. We need to import NumPy, Pandas, datetime, and random libraries. So we'll run this. Next, we're going to create a new data frame, and we're going to do that by importing a CSV file, read_CSV, and then the name of our file, which is iris.data. And then we're going to put names. These are the column names. A, B, C, D, because we have 4 columns of numerical data, and then we have a label, which is a text. And then we'll print out df.head. So this is the first way that we can select data to show. Head allows you to show from the top of the data frame any number of rows. The default is 5, so if I don't pass in any arguments at all, head will show us the top 5 rows. Or if I want, I can put an integer argument in there and it will show the top 7 or 9 rows, or however many you want to see. So you don't have to print the entire data frame. I'm just going to show the top 5 here. We'll run that. And here we get the first 5 rows of the data. So we can see that when we imported the CSV file and loaded it into a data frame, it automatically assigned integer values for our row indices, starting with 0. So that's normal. That's how Pandas works. And you see our column labels across the top. These are called the names, A, B, C, D, and label. And you can see A, B, C, D are all floating point values, and they all have 1 decimal place. So this is a nice clean data set to work with, and there's no missing values or anything. So head is the first way to slice off data from the top, and then if you wanted to slice data from the bottom, you can use tail. So we can use df.tail. And if you want to pass in an argument, again, you can say 3, then it'll print the last 3 rows of data in our data frame. So we can see how many rows there are, right? 0 to 149, there are 150 rows of data in the data set. And if we wanted to, we could also put df.shape, and it'll tell us that there's 150 rows and 5 columns of data. So that's the shape of our data frame. Next, we're going to look at the loc function. So loc is short for locate. We can do df.loc. And then we're not going to use parentheses for this. We're going to use square brackets, okay? This is a method of indexing. So we're going to take indices 146 onward. So there's a from, a to, and a step. This kind of works like the range function or some of the standard indexing that you're used to from Python. So 146 onward, and we just leave the onward blank. Now, if we wanted to, we could type 150 here, and then we can also put an increment of 2, right? Every other row, if we wanted to. I'm going to leave the increment blank, which means every row, and I'm going to leave this blank, which means it's just going to go to the end. So that gives us 146 onward, and then if we did df.loc, and then let's say we put a range in here, let's say 54 to 59. And we can, like I said, we can put every other row if you want to. 54, 56, and 58. So the loc function is useful for selecting rows of data numerically. But these row indices can be strings also, and you can use the loc function for strings as well. And if you leave the from and to both blank, and we just put in the increment or step value, we can say from the beginning, because we're leaving that blank, and then to, okay, we'll leave that blank too. And then we'll put just an increment value, let's put 40. So it'll print out every 40th row of data. Whoops. df.loc, and then it'll print every 40th row of data. So we get 0, 40, 80, and 120. So you can just put the step if you want as well. Using loc, you can also pass in a list of rows. Let's say I want rows 5 12 and 17 to print out. So we can do df.loc. And then here's what we're going to do though. We need to put a double square brackets here because we need a set of square brackets, a list, inside of the square brackets. So what did we say? 5, 12, 17, whatever. You can pass in any list you want here, but you just need to make sure that you have 2 opening square brackets, 2 closing square brackets for your list. And then let's see, we get rows 5, 12, and 17. So you can pass in a list of rows as well. If we want to print, let's say, a column of data, we could print the column of data, B. A couple of different ways to do this. We could say just df.b, and that will give us column B. Print that. So that will give us column B of the data. You can see this is column B. You can also use the square brackets. So we can also do this. And then B is a string, so we're going to put that inside of quotes. And this will work as well. This does exactly the same thing. Boom. That will give us column B of data. And if we want, let's say, a list of columns, we could put B, comma, D. And then we need 2 square brackets. Boom, that will work too, see? 2 square brackets to open, 2 square brackets to close. And so we have a list of columns that we want to print. So we can do that. And then you can also, you can add on to here dot head if you just want to see the top 10 rows of data. That will work as well. All right. So it's going to give us the top 10 rows. Or tail. Those functions work by tacking them onto here. Now df.loc is pretty versatile. You can also combine a range and a list of items. And you can combine both rows and columns if you want. So check this out. We could say we want rows. Rows are going to come first and then columns. So we can say that we want rows, let's say rows 50 to let's say 60. And then we put a comma, and now we have a field here where we can put columns. So which columns do we want? Well, oh, I just want column A. Okay, that's fine. You just get column A for rows 50 to 60. Or if you want to pass in a list here, you could pass in a list. So we could say we want columns A and column label. And that will work as well. Whoops, we left a square bracket off there. So if we have that square bracket, boom. So again, we have a list for our columns that we want to show, a range with the colon for the rows that we want to show. And we use the loc function. And you can also put a list for the rows you want to show instead of a range. And you can also put a range here instead of a list. So loc is pretty flexible in terms of what you can do with it to isolate blocks of data. We can also use loc to filter data. So let's say we want to do df.loc. And then inside square brackets, we can put a filter here. df.a less than, let's see, what is A? Let's say less than 5. So it's going to print out the rows where column A is less than 5. It's going to print out the entire row. So you see how it skipped a bunch of rows here. Skipped row 10, skipped row 7, and so on. Actually, it didn't print that many rows at all because it's only picking rows where column A is less than 5. So we can actually do simple filters inside of the square brackets with the .loc. So if you want to try another one, let's see, df.loc, square brackets, let's do df of c is equal to 1.4. And here again, we've got the double equals because we need a Boolean result from this test here. We need a Boolean result from that. And this is going to look at, for each row of data, it's going to look at dfc and compare it to 1.4. And if it's equal to 1.4, it'll print out that row. It's going to print out the whole row. So that's how that works. It gives us all the rows of data where c is equal to 1.4. Let's say you only want to see the label for those, okay? We could do this, comma, label. Now it's just going to give us the label for those rows, where C is equal to 1.4. So loc is pretty darn versatile. You can do some filtering with that. You can filter rows and columns of data. You can select different rows and columns of data, lists of rows, and so on. And let's do another filter here with loc. df, let's do this. df d will filter on row D, and then dot loc, and then a square brackets. So we're going to filter on column D. We'll use a lambda function. Lambda, where our variable is x. What is x? Well, x is the D cell for that row, because here we selected column D. So it's going to take column D, x is column D, and if it's greater than 2.1, then it will print it out. So it's only printing out rows of data where column D is greater than 2.1. And you can see all the ones here that have greater than 2.1. And then it tells us at the bottom, name D, because this is column D that we just printed. Those are the row numbers or row indices. So again, we can use simple lambda functions. I don't believe more complicated lambda functions actually work with the loc. But simple lambda functions work pretty well with loc. I'm going to show you a way to do more complicated functions too, though, for filtering, so hold tight. Now, Pandas also has this thing called iloc, and that is integer location, which is a little more complicated. df.iloc, integer location, let's say up to 10, let's just say, and run that. So what it's going to show us here, it looks like it would just be looking at these row indices here, and it's picking up to 10 and printing them out. That's actually not what's happening. So what integer location is doing is it has a separate index that we can't see. And it has an index for rows and it has an index for columns. So A is column 0, B is column 1, C is column 2, D is column 3, and label is column 4. So we can select column 4 and that will give us the label using iloc. Or we could select row 3 and it will give us this row. But it's incidental that this row happens to have this index 3 here. So I'll show you what happens when we change our row indices. When we still select iloc of 3, we're going to get this same row of data, 4.6, 3.1, 1.5, and 0.2. So let's change our row indices, and then you'll see they print out differently here. Let's say df.index equals, and then we'll put I for I in range 0 to 750 with step of 5. What did we do up here? We said df.iloc up to 10. So let's try that. Copy that, and then we'll paste it down here. And what you get is kind of not what you expect. You think you're going to get ones where the index, see what this did was this changed the indices from 0 to 750 with increments of 5. What now looks like row 5 used to be row 1, right? That's the same data. So we have row indices in increments of 5 instead of row increments of 1. And when we use this iloc, the first 10 rows of data, it's literally giving us the first 10 rows of data. It's not giving us ones that have row indices less than 10. If it did, it would only give us 0 and 5, right? But no, it's actually giving us the first 10 rows of data. So in other words, there's a secret hidden index that we can't see here that that's a numerical index just like a list would have, where the first row is 0, the second row is 1, regardless of what this row index says. And that's what iloc uses. So iloc just counts from the very beginning of the index, 0, 1, 2, 3, 4, 5. So regardless of what your index is, iloc just counts numerically from the beginning. And it does exactly the same thing with columns. So you can select rows and columns of data with iloc just like you can with loc, except that it's using numerical indices for the rows and columns. So let's do a few more examples with iloc. So if we want to see df.iloc, put some square brackets here. Let's say no beginning and no end, so all the rows. And then we'll put a column index. Let's put a column index of 1. that would be column B, right? So that's going to show us column B of our data. And then I'm just going to print, let's say, the first 6 rows. So that gives us column B, which is column 1, uses an integer location for the columns just as it does for the rows. And let's try another iloc, df.iloc, square brackets, 1 to 7. So we'll get rows 1 to 7, just column 2, which is column C, right? Return, so we've got column C, rows 1 to 7, which has row indices 5, 10, 15, 20, 25, and 30. So you can do pretty much the same things with iloc as you can with loc, except that you, instead of using the row or column index name, you're using the integer location of that row or column of data. So there's another, I think, fairly powerful way to filter records, which I really like. This is df.query. So df.query, and you can do more complex queries with this. Now, instead of using square brackets, we're going to use parentheses. So this is not indexing, this is actually a function. So we need to pass in arguments to that, and what we'll pass in is a string. So we have quotation marks to open and close it out. It's a string, but what it is a string that has a Boolean evaluation. And we can put in column indices for this. So B compared to C, right? B greater than C and C less than 4 times D. So we're doing 2 comparisons and ANDing the result together and then printing out only the rows that match that. So you can do fairly complex queries on rows of data with different columns as your variables, right? Here we have B greater than C. Each one of these has B greater than C, right? And C less than 4 times D. So it's multiplying D times 4 and comparing that to C, and C is less than 4D. So you can use AND, or you can use just this bar here for OR. That's the OR symbol. You can also type out AND, and you can type out the word OR. Those will all work. So a single ampersand works just fine. And then you can use greater than, less than or equal to, equal. Anything that gives a Boolean result, any comparison that gives a Boolean result, make sure you have these quotation marks around your string, around the whole thing. And you can even do, as you can see here, multiplication inside your comparison. So this query is a super powerful feature for doing fairly complex filtering on your data. I think it's a simpler way to do it than trying to figure out how to do it in loc sometimes. Let's try another query. df.query, and then parentheses, and we'll test if A is in 5.7, 5.9. See how this is a list? Hopefully you're already familiar with the fact that in Python, you can test membership in a list by just saying A in or A not in a list of integers or whatever, a list of items. So what this is going to do is it grabs the value from field A here for each row, and it tests if it's in this list. So this basically is just going to test each row to see if A is in that list, and it'll print out the rows that have one of those 2 values for A. So that's pretty cool. You can see the result here. You get all the rows that have either 5.7 or 5.9 for A. And you can use in or not in. You can also use equal or not equal. So in and equal basically does the same thing. Equal is not testing if A is equal to a list of items. It's testing if A is a member of that list. And this is testing if A is not a member of that list. That would print out all the rows that don't have 5.7 or 5.9 for A. Here's another query I typed up. We'll put parentheses and we'll just paste that in. B is greater than 3.5 and D is not equal to this list. So again, not equal means not in. I could type out the words not in if I wanted to, but what I'm saying is D is not in this list. So let's run that. And you see D, so it's 0.4, all these 0.3 are not in this list. And B is greater than 3.5. So you can put as many Boolean result tests as you want, and query can handle anything that's ANDed or ORed together. So really awesome feature for querying the data. Query is easy to use and it's very intuitive. Now we're going to change gears and look at slicing time series data, because there's some important features here that you need to learn. A lot of people are using time series data in Pandas, so it's important to understand how to access and slice that data the way you want. So we're going to use a different data set. We're going to use the pivot.csv file. This file is in my GitHub site and the link is below, so you can grab this file if you want. Now when we load it up, we're first going to transpose, because I've got the dates across the top axis instead of across the side axis. So we first transpose the data. We're converting our strings that it imports for the index to datetime objects so that they're not strings anymore. Now they're actually datetime objects for our index. And then we're renaming our column to, there's only one column, I'm going to rename it from 0 to A. And then I'm going to print out the shape, and I'm going to print out the first 8 rows of data so you can see what that looks like. So now we have a datetime object as our index, and we have column A of data, which looks like floating point values, right? And there's 100 rows of data in one column. So let's look at how we can slice these time series data frame, or basically ones that have a date here. We want to filter them by dates. So this is df1. I'm going to say df1. We can get a specific year of data just by putting the year in. So let's say I only want 2004. We can do that to get 2004. And since this is a datetime object and not a string, this would not work if this first index was a string, right? But since it's a datetime object, Python knows how to parse this out of this and do a comparison. Since it's a datetime object, Pandas has the ability to do that. So I can just pass in the year and it will compare it to the year part of these dates, which is really cool. So it's that easy to just filter out year. And we can do df1 and then let's see, square brackets. So this is a range of years. It will print everything up to and including 1996. That gives us what, 1995 and 1996 years. So we're just slicing with the from and to index, but we didn't put anything for the from, so it means from beginning up to 1996. And we can do, let's see, this. We can put in a date as a string. So 2013, this would be what, October 1, 2013, up through the end of 2015. So that's a date range. This doesn't look like a normal date, it's a string, but Python knows how to interpret that and convert it to a datetime object so that it can compare. So let's watch this work. Everything after October 1, 2013. So we get some in December of 2013. We have some 14s and 15s here. There's one in November of 2013. See, so it only selected rows that are after this date and up until the end of 2015. So it's pretty cool to be able to filter dates just by year, or even by putting in a date as a string like this, using just square brackets, nothing more. Now we could also use the iloc function if we wanted. I think that would also work. And as our last little test, df.query, boom, we'll put in a query on column A. So column A has to be between 0.9 and 0.85. So it should print out rows. Oh, we didn't get any. Oh, okay, we got to put df1 here. Let's see, here we got 2 rows that are between 0.85 and 0.9. So you can also use df.query on our time series data on column A, which is cool. I hope this video was helpful for you. If so, please click the like button and subscribe to my channel. I'm Joe James. Thanks for watching.